Hi guys, this is Ivan Lima, and on this video we will talk about the SQL Server architecture and internals for developers. The main goal of this video is to, by the end of the video, understand how the main components worked works with the queries that we prepare every single day and how we can improve our queries in a way that's going to make better queries so that the DBAs won't be mad at us, so that the users will be happy because the data is coming fast, and that we will also become better developers. The components that I want to talk about are the protocol layer, the relational engine, the storage engine, the buffer pool, and also the physical files, transaction logs, and data files. So this first part is the protocol layer, which is actually not a file or anything. It's basically a configuration that we can see on the SQL Server Configuration Manager. As you can see there, if you look for the SQL Server Configuration Manager in your server, you see those protocols shared in memory, named pipes, and TCP/IP. And this is pretty much a wall so that the user or whoever is trying to retrieve data or make any type of manipulation of the data is actually someone who is authenticated and authorized to use the data. The way that the queries are sent are usually by, not usually, but always by tabular data stream. That's the way that it is recognized in the engines in SQL Server, and it goes through this SNI or SQL Server Network Interface. Let's talk about each one of those protocols, starting with the shared network. So every time you run SQL Server from the same machine where your client and the server is installed, not every time, but if you're using Windows authentication, you are using shared network. It's just when the client and server lives in the exact same place. That also can happen with SQL Server authentication as long as client and server is in the same place. This is very common among developers who is developing a local host. The other one is the named pipes, which gives some flexibility on where the client and server lives. However, it has to be on the same area network, so it's the same LAN, right? The port number there is 445 as default. That can be changed. This is not very used, mostly because if I can use a named pipe, that means that I can also use a TCP/IP. In TCP/IP, since it's a one setup, it's an easier setup. It is usually preferred over this one. Now, this one can be used though for companies with restrictions on only people on the same network would be able to use it. So maybe it could be set up in that way, but even then, not very used. The next one is a TCP/IP, which already we already know what it is. It's based on IP addresses. Um, Developers and users will most of the time use this one as well. If you're a developer not developing your local host, you're probably using this one. And you, as a user, since you're probably not always never going to be in the same local, the server won't be in the client and server won't be in the same server. In that case, you'll be using this no matter what. So here on the square in the right side, we see that I have, that's what I see in my computer, the SQL Server Configuration Manager, and that's what it's saying is that since I have SQL Server installed in my machine, it's enabled to be used only as a shared memory. So if someone tried to IP into my SQL Server or use name pipes, they won't be able to because those are disabled anyway. The system administrator and DBAs are the ones usually responsible for that. As a developer, you don't really have to know much about enabling or disabling or doing any of those things, but it's good to know that sometimes you might hear those terms and you would have to who to look for in order to make your connection work. Once the data gets out of the protocol layer, now it goes to the relational engine, which has three main components: the CMD parser, the optimizer, and the query executor. People call this one as the query processor, and the reason is pretty simple. Let me read what is a relational engine and what it does. So the relational engine will receive the query, validate the query, an object being queried, create execution trees for the query, find an optimal plan for the query based on the execution trees, and later connect the plan with the storage engine using the access methods. So can you notice that we talked about a lot about queries here? It's about the query. Relational engine will take care of the query in every single way you can imagine. So it will process the query. That's why they call it query processor. So it has nothing to do with the data at this point. It only has to do with the query. Going a little bit deeper on it and going to the first component, the CMD parser or command parser, there are three main functions that a command parser does. One is syntax validation. So it's going to check that the word that you put in the statement actually can be read by SQL Server. For example, select. If you misspell select, it's going to say, look, this, we don't know what it is. So please send us, it's going to send us an error and you're going to have to fix it. As developers, we will have to fix it. The second one is semantic validation, which is based on the object inside of the database. So if I do, for example, in the example below, select star from person, if person is not a table recognized in the database, the parser will say, okay, this object does not exist, and for that reason, I cannot select, cannot do anything. So fix that so that I can give you something. So those two things, they happen without having to touch the database very much. Why? Because I don't want to, in a busy database, I don't want to the wrong statements be syntax or semantic to be coming into the database and to be clogging my database with things that won't even give any type of return. Now, the next function of the parser is the query tree creation. And I want you to think of this. We have these two examples below, select star from person and select star from address. If you see the joins, you'll see that at the end of the day, this will return the same output. So the query tree creation, it will pretty much look for options based on the query that you sent. It will look for all the options of other queries that will actually yield the same result so that the optimizer can later on work on it and find the optimal plan based on those choices. So now going back to the going forward to the optimizer, I put it there. The optimizer finds the optimal plan, not the best plan. What does that mean? Sometimes as developers, we think that we don't really have to care much about the SQL that we write because the optimizer will take care of finding the best plan possible based on the query tree that we'll create. However, that's not true. The optimizer cannot be all day long looking for the best query. And the optimizer also knows that we need a result as soon as possible. So if we send a query with many joins, with subqueries, with whatever it is, and we expect the SQL Server will analyze and will find all the possible ones, and then based on that, get the best one, we're wrong because the optimizer has a time limit as well to say, okay, I need to get results as soon as possible. Before I do the results, I need to find a plan. So based on whatever amount I'm able to analyze, I'm going to do that, and I'm going to get the optimal one out of those. So that's not the best plan. It's the optimal or the best on the ones that the optimizer was able to look at. Those are the three steps that it takes: the trivial plan, the transaction processing plan, and the processing and optimization. Now, it's important to understand that if the plan already exists in the buffer pool, and we'll see more about this later, then you won't have to do the optimization. Okay? And why would the plan already exist? Well, it would exist because someone before you already tried that query, and now that live in the plan cache in the buffer pool. Here's a little explanation on that. So once we have all this query tree coming to the optimizer, the optimizer will, through a process, will actually go to the buffer pool, check on the plan cache, see if there is any plan associated with that query, and if there is, that plan will be returned to the optimizer. So the optimizer now didn't have to do anything really except go and look for that query. If it finds, great. If it doesn't find, it will then proceed with the execution plan creation. This is for performance purposes, and we will understand this better when we do the demo. Now, the relational engine also have the query executor or query executor, whatever you want to call it. Well, the main function of this one is pretty much to receive the plan that was chosen by the optimizer and send to the storage engine. In that case, going to another component called the access methods. That's the main purpose of it. It won't do anything else as far as development. Now, let's start talking about the storage engine and the components there. So we have the transaction manager, the access methods, and the buffer manager. Previously, we said that the relational engine takes care of queries. Well, the storage engine on the other side takes care of the data. The only place where there will be some query mentioned here will be on the access methods, which doesn't really even receive the query. It only receives the execution plan, right? So we don't even have a query come here. So it's the execution plan that it receives, and then the access method is this gate. We will talk about that in a bit, but which based on the type of execution plan that comes, it will know what to do. And here it is. So access methods manage what goes where. So once the execution plan comes, the access method will check and see, okay, is this a update, insert, delete, merge, or is this a select? If we're talking about insert, update, delete, it will send it to the transaction manager. If we're talking about a select, it will send to the buffer manager. If it's an insert, update, and delete, it will also go to the buffer manager. We understand that later. But before, it will send to the transaction manager for the durability property of the asset properties of the database. Let's understand a little bit more about the transaction manager. So once the execution plan hits the access methods, and the access method see that it's a DML command with insert, update, or delete, and it has to send to the transaction manager. Now the transaction manager will also have to make a choice. It will put things in the transaction log or not. So that's the main function of the transaction manager. As of now, we're talking of things that live in memory. So the relational engine and the storage engine, they both live in memory. So any of the statements that comes with the transaction manager, it will live in memory for now. Unless we're using a commit. So if the statement or the query we're using, it's inside of a transaction scope, we have the option to do a commit or a rollback. Up until a commit happens, things will live in the transaction manager. When we do a commit, it will be the first time that something is going to be written in a file, and it will pretty much be whatever hash statements that has to be to the logs. Okay, so if we do an insert and we do a commit, it's going to go to the transaction logs. That's the first time the transaction log is going to see anything in it. But if you do a rollback, that's not even going to touch the transactions log. It would just like it never happened. It lived in memory and it died in memory. So that's what the transaction manager does, right? The same for the updates or delete. And the reason why we are starting to see now things written in the disk is because to be durable, we have to have that written somewhere, right? As of now, up until the transaction logs, everything we talked were in the memory. And if the computer is turned off, there was, I don't know, whatever happens to that computer, if we lose that session, all those things could disappear if we didn't have something written in the file. But the transaction logs do not hold the data yet. It only holds the statements in a form, whatever form it hashes. Okay, so we will talk more about this in a bit when it goes to talk more about data files. But just keep that in mind. The commit will make transaction manager write into transaction logs. The rollback nothing will ever gonna be right in the transaction logs. Now, what about the buffer manager? So the buffer manager has three main responsibilities. One is to retrieve data from the data cache in the buffer pool. And remember, data will always, and I put that in capital and in bold so we don't forget, data will always come from the data cache. Buffer manager will ensure that. It will also, another function of buffer manager is to insert query plans in the current plan if the current plan does not exist, right? So as we saw before, if the optimizer has to create one, it will be inserted here. And if it already has one, then it doesn't have to be inserted because it was already there. The optimizer didn't even have to do anything about it. So it will insert those query plans if needed, and it will also help on the dirty on the to clean dirty pages. So let's jump to buffer pool. I will talk more about the dirty pages in a while, in a bit. But let's jump back to the buffer pool so we can get the context to understand what are dirty pages for those who doesn't know. Okay, so here we still have the buffer manager. He got the execution plan from the access method saying, okay, this is whatever DML command that we're talking about. And what that's going to do is, again, as we said, it will send that information to the query, the execution plan. It will send that to the buffer pool in the plan cache, and also manage data that's in the data cache, right? And how that happens is that the buffer pool then it holds the two main components that we have to remember. There are more, but the two main ones are the plan cache, which has those execution plans, and the data cache, which has smaller pieces of the data files. What do I mean by smaller pieces? So the data files, as you can see, they are physically stored. They're not in memory, they're in the hard drive. Repeating again, physical reading or writing or modifications or whatever it is, it's expensive, it hurts performance, and we want to avoid that. SQL Server will always do that. It will always try to, well, not try, it will always make sure that it doesn't go to the data files or modify it. When I say it doesn't go, it doesn't go directly to the data files. If as a user I send a command and that command doesn't exist in the data cache, it will not go directly to the data files. You might go to the data files indirectly and do stuff, and we're going to talk about that. But it's never. It will always, the data will always going to be retrieved from the data cache. Okay, but before that, there'll be a process that will put some of those pages of the data files in the data cache. Some of the existing data will already live there. Well, unless you just starting the SQL Server for the first time, then it will have to build out of there, out of the inserts and things that's going to start to happen there. But or if you reboot the system, there's nothing in the data cache. So once you start sending queries, it will start picking up data from data files and putting in the data cache. But the data cache has 8K pages, just like the data files, but it's just not all of them, because we're talking about RAM memory here. So if we have a database that's like 1 TB of data, how are we going to put that all in the memory? We can't, right? There's only a portion we can put, maybe 10 gigs, 20 gigs, I don't know, whatever it is, 30 gigs. And so I'm going to be able to have a portion of that database inside of my data cache. And that's what I'm going to be go off with. That's what I'm going to try to, when I do a query, and we will see in the next slide, that's what we're going to try to do it. That's how we're going to try to make things work. Okay. So it's just a copy of the data files that lives in memory, so it's faster. Okay, but it's not all the files, because it just can't hold all the files unless your database is extremely small, which is probably not. In that case, you wouldn't even be using SQL Server. Let's talk a little bit more about this. As you can see, I have the plain cache and the data cache. They're moving. The reason they're moving is because they keep changing. They're always changing based on certain things that happens. The data files, as I said, they live in the physical disk. It's the actual persistent data. It won't go away unless the drive breaks or someone purposely delete that file, which is what happened to any type of file, right? If someone deletes it or if the hard drive breaks, that's the only way it's going to go away. Other than that, it's durable. It will never go away. And I'm emphasizing here again, data will never come straight from here. Data will always come from the data cache. Now, I put there a checkpoint because I want to talk a little bit about checkpoint. We talked on commits and rollbacks, right? And we said that the commits will write things into the transaction log. Rollback will not even make that consideration to write into the transaction log. But what about what checkpoint does? So checkpoint is an expensive command because it will make the data files to be written based on the data that we have in the data cache. Oh, I don't understand what you're talking about. Okay, let's come back here, and then this is going to clear up a lot of questions. So let's imagine we have the insert, update, delete, and select as examples. And taking up the asset properties, especially the durability one. So we understand that the data, once it's committed, it has to be there, right? But we're talking a lot about memory and not too much about, we're talking about a lot about like RAM memory and not too much about physical memory. Because again, we don't want to be writing into the physical memory. We don't want to be touching files too much, otherwise, because that's what's gonna degrade. It's gonna make my database be so slow, right? So how does it work? Let's imagine this in the let's imagine this let's say that we just have this new database inserted or installed in our server, and we're going to do our first insert ever. We have the tables there in place, and we're going to do our first insert ever. When I do an insert, the data cache will capture the way, assuming that everything is good, the tables exist, everything is there the way it is, the way it should be. I have no problems with my query, so I do an insert. So the data cache will have to capture the structure of the data files for that insert, right? So it goes actually into the, whenever do they insert, if we don't have anything in the data cache through a process, we'll have to go, the buffer manager will have to go through the data files, capture the structure, put in the data cache, and now I know how the insert works, and I put that insert in an 8K page in the data cache. Well, that data still doesn't live in data files. Okay, let's say that as soon as I started this database, it became extremely busy, and I don't want to be writing data files a lot, so it's just going to go straight to the data cache, and it's not going to be the data files. Now, understand this: we have no record in the data files, and we have a record in the data cache. That's what we call a dirty page, because the data is not the same, the data files and the data cache. The data is just not the same. That's a dirty page. Okay? So now let's say that 5 seconds later, this was not still written in the data files. I make an update. And in the update, because I saw that I did something wrong in that record, I make an update. So now when the execution plane comes, it comes to the buffer manager. It's going to go to the data cache and look for that record. And I find that record in the data cache. That record is still not in the data files. But an update is going to happen right there in the data cache. Now, let's say that 5 seconds later, I found out that everything was wrong. So I just want to delete that record. Again, it's going to come. It's going to go to the buffer manager. It's going to go to the data cache. It's going to look for the record there. Oh, the record is there. So I'm going to delete from there, and I'm done. It never even touched the data files. Well, for now, you say, okay, so in that case, the data is clean, right? Yeah, I mean, if you think about it, the data is clean because that record never existed, never went to data file, never wrote a thing to the data files. But the problem is, what if I did an insert in an update and I never did a delete? And that record does not exist in the data files. And what if the computer just turns off for whatever reason? We lose connection, we lose whatever it is, and that memory goes away. The data cache memory goes away. That never got written to the data files, right? So that's why for DML statements like update, insert, and delete, it has to go first to the transaction manager. Because once I do a commit, if I commit, that means that data must be there, right? Isn't that the durability property? So once I do a commit, that is going to go to the transaction log, which is a less expensive way to put that query there than just put the data in the data files. So if I now lose the data cache, that information can be retrieved from the data log, once it returns back the server, it will put that data into the data cache and eventually send to the data files. And we'll talk about that in a bit. So that's why it's so important that when we do an insert and update and delete, that goes first to the transaction manager, who will, based on a commit or rollback, will put that information in the transaction log and then do the modifications in the data cache. If you don't do a commit, then what's going to happen? You're going to lose the whole thing. But if you didn't have a commit, it's probably because you probably didn't want to, or it's just a bad development practice, whatever it is, right? But if you did a commit, you ensure that that data will be there. So what happens then now? Like how is this even gonna write to the data files, right? So let's go back to the example I was given. Let's say I do an insert. First time the database is there. That insert is gonna go into the data cache, okay? And let's say that the database is not that busy. It's idle there, or there's not many transactions coming. What's gonna do is the lazy writer will flush that down eventually and take that data and put into the data files. Now we have synchronized data. The thing is that record won't also be in the data cache anymore. Okay, and if I have to make a modification in that data, what's going to happen is I'll have to capture that data from the data files, put back in the data cache, and do whatever modification. For example, I did the insert. Okay, then that data got inserted into the data cache, system became idle, and I got that inserted into the data files using the lazy writer. And the reason it's called lazy is because you want to be lazy. You don't want to be working all the time because it doesn't want to be writing the data files. So put that in the data files, and now I need to, after 10 minutes, things were flushed to the data files. I need to do an update on that record, right? I go to an update, go to the data cache. That data is not there anymore. It's in the data files. What the buffer manager is going to have to do is going to have to grab that data from the data files, put in the data cache, and do an update there. Once I grab that data in the data files, put in the data cache, they're the same. Pages are clean. Once I do the update in the data cache, now the page is dirty again. That means that it's just not the same data. I have contradicting data. But the data cache eventually, with the use of the lazy writer, will capture that change again when the system is not too busy, and it's gonna put back in the data files. Same with for delete. If I have to delete a data, the data is not there in the data cache, the buffer manager will capture that data in the data files, will put in the data cache, and it will delete there, and eventually that will be deleted in the data files. So it's just a way of ensuring that we always picking up data from the memory. Now, if we're talking about a very busy database, what's going to happen is, as you can see, that thing keeps changing, rotating the data cache, because that it's a process that keeps happening over and over. I always have different type of data there based on its usage. If we have this type of data that's used all day long, that's probably going to be all day long the data cache, because it's doing insert. I'm sorry, not insert, but it's doing. Let's say that I do have this update that I have to keep updating that same type of record or the same type of set of records all day long. That might not touch the data files for a while, up until the system gets idle, and then it does. Now, sometimes if the memory is full, the RAM memory is full, and it just can't hold anymore, then the server will have to say, okay, you know what? I have to do something about this. I have to start making changes, especially if I cannot hold more changes in the transaction logs or in the data cache. I'll have to start flushing that to the data files. So maybe sometimes you might see that during a period of the day, the database is slower. It's most likely because it's cleaning the pages. It's saying, okay, I have to clean the page now. So I've seen, for example, usually where I work, it comes like 11:30 or noon, things get extremely slower. And maybe it's because some of the applications start running that time since there are not many users. And that slows down the system because there's so much dirty pages that it needs to clean it up to ensure durability. Another way to ensure that things are cleaned is by using the checkpoint that I mentioned before. So the lazy writer, we not even the DBA has control over it, but a checkpoint, as developers or DBA, anyone who has access to the database, they're able to issue a checkpoint, and a checkpoint will pretty much synchronize the data cache with the data file. So checkpoints here, they're good in a way, but they're also bad because if you have an application with a bunch of checkpoints, you might be hurting your database. Why? Because every time you do a checkpoint, it will clean those pages and send them all to the data files. One of the difference though between the checkpoint and the lazy writer is that the lazy writer will flush that data from the data cache and it will pretty much have everything there empty again so you can keep putting stuff there, putting different stuff there. The checkpoint will not. The checkpoint will just synchronize the data files in the data cache. So now we have the same data, but as soon as an update or delete start coming or insert, we'll keep having we start having dirty pages. Now talking about select. What happens to the select is again when we send a select, that information goes to the buffer manager who is going to go to the data cache and is going to try to find that information there. If that information is there, and remember, if you made any type of updates before, it's gonna be the updated data, right? So you're always gonna have the current data there. So unless we're talking about unless it's in a transaction scope where whoever is using the transaction is not doing a commit yet, in that case you're gonna get the old data. But otherwise, if you went to the transaction log, you're gonna have the most current data, right? So now you go there, you grab that, and again, let me just say one thing. Depending on locking mechanisms, I don't want to talk about this right now. Anyway, it goes there, it looks for that data in the data cache, and if the data is there, great, it returns to you right away. That's going to be easy, it's going to be fast, no need to go to data files. Let's say that data is not there, then the buffer manager will make sure that it goes to data files, pick up that data, put in the data cache if the data exists, of course, put in the data cache, and then select from there and give to the user. That's going to take a little longer. So it's always better to go to the data cache, right? It's always better to have that in the data cache. And that's why the most often queries are in the data cache, because if I'm selecting the same record over and over and over, the data cache is going to say, okay, great. So yeah, I just don't need to go to the data files. But if every once in a while there's like this query that it's rarely used but we need it, that's going to go to the data files, pick up that information, put in the data cache, and then it's going to bring back the information to the user, and that data will be there for a little bit. But if it's not used again, eventually when the lazy writer flushes the data, that one's going to go away, and we're just not going to see that anymore unless unless we have to do it again, and then in that case we're going to go to data files. So that's the main difference between commit, rollback, and checkpoint. Commit will write into the log files. Checkpoint will write into the disk files, into the data files. Now, let's see some of the demo here and see how that works for plain cache. Okay, so now we're going to see when the statements are cached, in what type of statements do actually get cached. So let's use this table called course. I have no tables in here, and I'm going to create this table called cache. And just so you know, the DBCC Free Pro Cache is just a way to clean up the query plans from the cache. Okay, so I'm going to do this, make sure nothing is there. The way I check if something is there is just by running this other query here, and if I run this, I got nothing there. Okay. So now I'm going to create a table that is created, and I want to see if any type of cache was created. As you can see, nothing is still there. That means that DDL commands, or data definition language commands, they do not get cached. So if you try to truncate, if you try to drop any of those statements, it won't be cached. And that makes sense because if you think about it, that's not the type of statements that we want to be running all day, every day. Right? It's something that it's run once during database design, or maybe to add a table here and there or drop it, but it's not something it should be done every day, especially by the users of the application. Now, if you go to the DML commands, and let me make sure this is free again, and I do that by executing this now and see that it's still clean, right? I can come here and say, you know what, I'm going to do few inserts. So let me insert like, I don't know, 3 times in here, and then let me delete twice. If I run here the plan, I'll see that I have this execution count for the insert, which I did 3 times with the number 3, because it's just say, okay, this one has run 3 times. And the delete statement, which I did twice, he told me that it was 2 times. And even though I run this 3 times, it didn't create 3 plans. He only created once. And now he knows that's about the same thing, so you won't create it again. You only created that time. Same for the delete. Okay, so now we also can conclude that DML commands, they are cached. I didn't put an update in here, but if you try update, you'll see that they are also cached, just like the same as insert and delete, and even merge. If you do a merge, that will also happen as well. Okay, so let's move on to DQL/DML commands. And the reason I'm calling DQL/DML is because some people like to say that select is a data query language, not a data manipulation language. And others say that it's just a data manipulation language. I don't really care as long as we know what we're talking about. Okay, so I just free the cache here. And if I try to see what's in there now, don't see anything, right? And now I'm gonna do this first one once, the second one twice, this third one without a comment. I'm gonna do that 3 times, and this last one taking the comment 4 times. And now to the query plan. Well, it picked up the 3 and the 4. Oh, this one probably got cleaned up by default for whatever reason. But let me do this again. I want to actually them to all be there. So I'm freeing this up again. This I want to do once. This I want to do twice. This I'm gonna do 3 times. And this one I'm gonna do 4 times. Okay, and hopefully this time they're all gonna be there. Okay, great, they're all there. And here what I can see is the first one was executed 1 time. That's the first one. And the second one was executed 2 times. And the difference between those is that this one has capital select, this one has lower cap select, right? The third one, this one, the difference is that just this small case here. And this small case got also a query plan because it looks different than the other ones. And the third one, even though it's very similar to the first, because this is pretty much the same, however, I selected the comment. So the text that came is different, so SQL Server were not able to identify and say, okay, this one is this, or it's the same. So we have to create a plan. So as you can see, I mean, this is only, we have 4 different statements. They're pretty much doing the exact same thing, giving the exact same results, but I have 4 plan caches for those, when in fact I should only have 1. And I mean, this is only for one single SQL statement. What for a system that has millions of statements being executed every day? So you see how the problem can become pretty bad, very simple way, right? So that's why standards are important, because when we put standards like, for example, select should be all capital, or should be all lower, or should be whatever it is. If everyone follows that, and I as a developer create this select with a comment, and someone else create the same select without a comment, then now I have 2 different execution plans for the exact same thing when I shouldn't, right? So standards are important. That's the main reason why, because now I'm not clogging the buffer pool. And remember, the buffer pool is competing for memory with the data cache as well, which is also very important. And we're going to talk about that later. So let's now just try for store procedures. Okay, let's see what happens to store procedure. So we know the store procedure here, this is a DDL command when I create a store procedure. So if I do a create, I already free up the cache. So let me select here and see what happened. It's nothing there because this is a DDL command, right? We expected that. But what happened if I do a execution of the store procedure? So here it is. And now it's there, right? If I can execute it, let me execute this a few more times. So the creation of the store procedure, because it's a DDL command, it's not cached. However, the execution is. Okay, so from this video, we could see that DDL commands do not get cached, DML commands do get cached, DQL commands slash DML, in the case select statements, they do get cached, and how those standards are important to enforce that any DML command is written in a way that everyone knows, everyone is writing the same way, so that we avoid caches for queries that do the exact same thing. We also saw that store procedures, when we create a store procedure that does not get cached, and that also makes sense because we don't keep creating store procedures over and over, we just execute them. And when we execute them, the execution get cached. Okay, feel free to play a little bit more with this. That's how you're gonna get it. Try things different so you can see how that cache works. Okay, now that we saw that, I hope that we understand, we have a clear picture, a clear understanding of the picture that we see now. We should be able to understand what is the protocol A and what it does, what the relational engine does, how it connects to the storage engine and what that does with all the components involved in it. Also, what is physical and what is not physical. By physical, I mean what files are physical, and those are the transaction logs, the data files, in the buffer pool, how that lives in memory and how that controls or helps to improve all the results that's going to come out of a statement that we send. If you have any questions, please put in the comments. I will answer them to my best knowledge. And if there's anything here that you believe that's also important, because again, this was an overview of how it works, the internals for developers, but there always might be something else that's missing. Feel free to put in the comment, let me know. I'm gonna think to do a blog post on this as well, and from there, give also a better understanding and maybe do any type of corrections that must be done. And again, if you like this video, please subscribe so that I can keep bringing some of those videos in the best way I can. Thank you.